Now that we've talked about the structure and functionality and key methods in the Java phaser, it's time to turn our attention to walking through an example application that shows how all these things get used in practice. And this particular example is based on some documentation that's available in the Java doc for the phaser class itself. And so we're going to show how to use this in practice. This particular example is a little different from what we've looked at before. Remember, the other examples we looked at for countdown latch and for cyclic barrier use this GCD processing stuff. This example will be a little different because I'm trying to showcase some of the cool features of the phaser relative to countdown latch and cyclic barrier, and the GCD algorithms didn't really cut the mustard, as it were. So if you want to see the code for this, you should take a look at the EX26 folder in my Java 8 package in my GitHub repository. So let's go ahead and take a look at the driver program. I'll explain what we're going to do. We're going to start off by creating a list of tasks, where each task is called my task, a very boring name, but you'll see what it does in a minute. And what these tasks are going to do is we're going to end up generating S number of tasks. Let's say that's 10 for sake of argument. We're going to generate some number of tasks. And to do that, we're going to have a ranged closed method, which is a streams method. It'll generate values from 1 to n. So from 1 to 10, for example, if S number of tasks is 10. And for each of those numbers, we're going to go ahead and create a new my task. So we don't really care what my task does. We're going to make 10 of them. And so this uses the map to object intermediate operation from Java Streams to make a constructor reference call to make ourselves 10 new my task objects. And then we simply use the collect terminal operation to collect all these new objects up into a list of my tasks. Okay, so far so good. We're then going to show a couple of different variants of phaser. The first one is going to be the run tasks method. And this method is going to demonstrate the one task or the one-shot phaser that will run a list of tasks that all start at the same time. So this is kind of an example of using a phaser as an entry barrier. And then we're going to then run another test method called start tasks, which passes in the tasks and the number of iterations we want to run. And that will basically demonstrate using a phaser in a cyclic fashion that'll repeatedly perform actions for the given number of iterations, which in this case is S iterations. So this is illustrating the use of a phaser as a so-called cyclic exit barrier. So let's first take a look at having a one-shot phaser using the Java mechanisms we've talked about. So here's what this looks like. You can again go take a look at the code in the link at the bottom of the slide. So run tasks takes a list of my task objects. And the first thing it does is it makes a phaser with a value of 1. So what that basically says is it's going to implicitly register itself, where itself is the thread that's calling the run tasks method. So we have a parties count of 1. Then we're going to iterate through each of the tasks in the tasks parameter, which is a list. And for each task in the list of tasks, we're going to go ahead and first dynamically register that particular task. So we're going to tell the phaser, got one more for you. So there's a new party to add here. And then what we're going to do is we're going to go ahead and create and start a new thread. And this will run the task, whatever the task is, that is my task. It's going to run that task, but only after all the other threads have got a chance to start. So in this particular case, we're creating a new thread. And if you take a look here, we're going to use the arrive and await advance method, which will all these calls and all these threads will all block until all the other threads have arrived. And you'll notice that for all these things, we've always incremented the count of the phaser by 1. We've dynamically incremented the count by registering it before the arrive and await advance method is called. By the way, I also could have done something where I would have used bulk register ahead of the loop to say phaser.bulk register, tasks.size, and then I wouldn't have to do this inside the for each method. I would have done it in one fell swoop outside of it. But this is just showing you how you can do things in a more dynamic way. So arrive and await advance will block till everybody's ready to go. And so you can think of that as essentially a one-shot entry barrier. So all the threads are started, all the threads arrive and await advance. And when they're all there, then and only then can the task actually run to do its thing. You'll also notice that on the way out, after we go through this for each loop, the phaser says arrive and deregister. So that said, I gave you this call up here before to give you a count of 1. And that's because I wanted to wait until everybody else was up and running before they started. But I'm going to deregister myself at this point so that all the other threads can start running their task and I don't have to be considered any further. So this is a good example where we have this kind of calling thread used to initialize everything, and then it kind of gets out of the way. It's kind of like the deist model of theology, if you will. Let's now talk about cyclic phasers using Java mechanisms. So this will be a phaser that uses a cyclic model. And what it'll do is it will repeatedly perform actions for a given number of iterations. So in this case, we have a kind of a driver method called start tasks, which takes a list of my task objects and a number of iterations to run. And this is also available in my GitHub repository. And to make this more interesting, we're going to do a couple cool things. We're going to make ourselves a phaser, and the phaser is going to be an anonymous inner class. And we're going to go ahead and define the onAdvance method. So as you can see here, the onAdvance method is going to be designed to have the phaser iterate a given number of times. So what it's going to do is it's going to see if the phase is greater than or equal to the iterations parameter that's passed to it. And if it is greater than or equal to it, it'll return true, meaning we're done. Or if the registered parties equal 0, it'll also bail out in that case too. So the hook method that we're overriding here will determine when the phaser will terminate. You can see it terminate when all the iterations have completed or the registered parties equal 0. We now go ahead and use the phaser to register the calling thread. Just say, hey guys, I'm here. Notice we didn't give any parameters when we created the phaser up there. So what we do now is we say, okay, I'm the one that's going to set the wheels in motion. So don't let anybody advance until I deregister myself. And then for each of the tasks in our tasks list, we're going to again register the task. We could use bulk register, but here we're going to go ahead and register. And then what we do here is we do things a little bit differently. It's kind of an inversion of what we'd shown with the one-shot phaser. Here what we do is we create and start a new thread. And what that thread is going to run in a do-while loop. And the first thing it's going to do is it's going to run the task. And then after the task is run, it's going to call arrive and await advance. So what that does is it says run the task and then wait for everybody else to finish their task. And so that's a good example of an exit barrier. So it's a cyclic exit barrier. And the last thread that arrives will trigger the invocation of the onAdvance hook method. And then that will dictate whether or not we keep going. So if it returns true, then that means that we're done with the iterations. And when we're done with the iterations, when onAdvance returns true, then the is terminated method on the phaser will also return true because we're done. And so now at this point, the loop will be terminated because all the tasks have had a chance to run. And again, as we showed earlier, the calling thread, the one that sets the wheels in motion, will deregister itself and allow any other tasks that are in these loops to advance to the next phase after they get a chance to run the task. So that's the end of the phaser example. I think you'll agree that it's a lot more complicated than using the countdown latch or using the cyclic barrier. It's more complicated to program. It's more complicated to understand. So the main reason you'd want to do this is if you have a dynamic number of parties, and that's where it really starts to shine. This particular set of examples doesn't really showcase that feature in all of its glory. We could have rewritten these things with cyclic barriers, but I think you'll get a flavor for how you program this stuff. And these are very common idioms that you'll see. So if you do need to have a dynamic number of parties, then what we showed here would make it very easy to follow the same pattern in order to achieve that result.